Hello everyone. Welcome to today's session. Today we will be talking about OOPS concepts in Python. OOPS is called Object Oriented Programming. So as you know, in Python we can do various types of programming. You can write sequential programming, you can write functional programming, and you can write object oriented programming. So the object oriented programming is a real world thinking where you think each program building is like you are building a real world object. Okay. So in this session, we'll start with what is object oriented programming and we'll dig further into each of these concepts and how do we write programs using object oriented programming. Okay. So first, let's see what is object-oriented programming. So object-oriented programming is a way of writing code that organizes data and behavior into reusable objects, like mini programs that represent real-world things. Example, a ride, a bank account, a student. So each object. So what does this object hold? Object holds data that is called attributes in programming language, and actions are called methods that work on the data. So why do we need to work with object oriented programming? Why this concept has come? Okay. So object oriented programming has started to manage the complexity of large software systems. Okay. So if you want to write a small program, that is easier. Let's say you have to build a big program, something like an app of a ride share like Ola, Uber, or Zomato. It's a big complex system software. So to build that, you need to think of reusability, a higher level of reusability in terms of a real world object interaction. So to build such kind of large software, as program get bigger and bigger, it will become harder to manage those programs and to track which part of the code did what, which will become very harder to manage. So, to reduce those complexities, object oriented programming will help breaking code into modular pieces like classes and objects and encourages reusability, like you write once and reuse many times. And it makes code easier to maintain, test, and extend. Also, it represents real world scenario more naturally compared to other forms of reusability of code like functions or loops. Classes are higher level of uh, code reusability, and we have modules and packages on top of classes also. Okay. So in short, you can think object-oriented programming helps programmers think and code like as they are modeling a real-world softwares, which making complex systems by thinking in a very real-world thinking that we are interacting with the real-world objects makes programs simpler, cleaner, and more scalable also. Okay. So to learn object-oriented programming, there are eight core concepts, eight core steps that you need to go through one by one to master object-oriented programming. So first and foremost is classes and object. Okay. So before I move into classes, let me show you the reusability. So first, initially, we saw how to initialize a variable a is equal to 10, b is equal to 20. Then we saw how to work with a huge list where we have multiple numbers and using for loop or while loop, looping through all these lists and finding out addition of all these numbers at a time or subtraction of all these numbers at a time. Then we saw one more higher level list and dictionary comprehension. So these are data type level. So these are data level reusability we are building it. So this is the first level of no, reusability. So this is the lowest level of reusable program. So you have to define this again and again. So let's say I want to change the a value, then I have to manually come and change it here. Similarly, if you see, if you remember the functions we learned, DEF, when we define function, we take two values. So here we do inside the function a plus b, and then return this value, return this a plus b value, so that whoever calls the function, they can print the value of the function inside. So along with calling the function, we pass the values to the function 10 comma 20, something like that. So this makes our code reusable. So you can write this function once and reuse. So this is just one piece of logic. Let's say you have to write more generalized logic in such a way that it can be reused by different types of people who has different needs also. So that kind of reusability is called classes. Okay. So I have brought up here one diagram. So that will help you easily understand what is class and what is object. So consider you have wrote a big document where a designer of a class, a car maker, he first designs the car on a paper, like how the structure look like, how the dimensions of the tire, how the dimensions of the windshield, what should be the design of the car, what should be the length, breadth, and all those internal details. So the design part is called a class. So it's not materialized, it's not came into existence yet. Just we have designed in such a way that the designer designs once, but that can be reused by many other car models. So when he designs the class, or when he designs the car on a paper, in programming terms, we call as class. So what is the definition of class? Class is a blueprint that defines how objects should be structured. So defining a blueprint is called defining a class in programming. So in that blueprint, we will mention the properties, what properties that blueprint should have. So we may have color options, price options, kilometer, model, and the methods. So behavior of that blueprint. So what our blueprint is a car. So that car should start, go backwards, go forward, and stop. So that kind of blueprint, building on a paper, writing it, all the details is called class. But when you take that blueprint and convert into an actual car, that is called an object. So that becomes your actual object. So we are taking the blueprint, the part of the blueprint, and creating an object. So with that same blueprint, multiple models of the car can be built for different price needs, for different colors. So every time we access that blueprint to build different objects or different models of different variations of car, and the access part is called instance. So whenever we access class, it's called creating an instance. Then once we access the class, it creates an object. So the actual object is created when we pass these values to our template. So when I specifically say I need a red color car with price 23,000, and that can be drove. I need to drive it 1,200 kilometer model Audi, and all these methods it should have. So when I say that I'm pass this instance, this data to my template and it gives back the result, that is where the object is created. So now let's go back to our definitions. I hope this is clear for you. Now, what is a class and an object? Class is a blueprint to the instance. Okay, so the definition of class is a class is a blueprint that defines how objects should be structured. So in real world also, lot of the software programs are developed keeping this concept in mind of classes and objects. So that makes the programmer connects to the real world as well as we build modular programs. Then, what is an object? An object is an individual instance created for that blueprint. So, everybody has different needs, but they have the need of the class. So, somebody needs different color, someone needs different color. So, everyone's need is called an instance. So, everyone defining their own need is called instance of the class. And when they define their instance of the class, and when the dealer delivers that, that is where you can say an object got created. So every time a different user call the class, an object is created. So this is the syntax of the class. So class name, and you write the logic inside. And how to call the class, how to you need to create the object. So we can define a variable object is equal to class name. So when you do that, your object is created. So here you create the class, here you call the class, and when you call the class, an object gets created. So what's the purpose of the class and objects? As we already discussed, the purpose is to create reusable, consistent, and structured representations of real world entities. Okay. So, as we already seen, car and car analogy. So, let's see. Our class is a form of booking a cab. An object is a cab ride booked by specific user. So, everybody can book a ride from the Ola Uber app. So, they all have different needs. So, they will put uh, pickup location, drop location, and the price they get accordingly. So class is just the general behavior, and object is a specific user related instance. Okay. So when you book multiple rides, each ride is a new object. So suppose I book a ride today, that is a one object. I book a ride tomorrow, that is one object. I book a ride day after tomorrow, that is called another object. So whenever I'm creating a new object, I'm following the same structure. So my class will be same. So class does not change. So that is where our class acts like a blueprint. So let's create a sample class. Class is equal to a ride class. Class, ride, and pass. So I didn't write anything inside it. Okay. So I'm using class to create objects. So, so let me first write my class. So this is a simple way you can write the class. Class, class name, colon, and the logic. Since I don't want to write any logic right now, I'm just saying pass. So when I run this, our class gets created. So now how to access that class? How to call that class? So I need to say R1. Let's say I'm booking a ride. R1 is equal to ride. So when I say this, my object of the class is created. So what I'm saying, I'm accessing the class. So once you create a class, you need to call the class to use it. Okay. So when you call the class, an object gets created. So when you call the class, it's called instance of the class. Instance of the class. So this is the wordings we use when you call the class. When you say R1 is equal to write 0, it's called, we are calling this class write. So that is an instance of the class. So you are accessing the blueprint. And now when you access the blueprint, an actual object gets created. Object gets created. What is the object name here? R1. So these are the three steps, important steps, that is to work with classes at a starting point. These are very important points that you should remember to work with classes. Now let's say I want to call, let's first print this, print R1. You can see underscore underscore main dot write. So this is our class name, and this is the address. This is the memory address where our object gets created and stored. Now let's say I want to create one more object, R2 is equal to write 2. So when I'm calling my class, one more object gets created. It's called R2. So when I run it, you can see both of their memory addresses are different. So this is R1's memory address and this is R2's memory address. Okay. Yeah. So why, what happens? Let's say I do not use class for software program. What happens if I do not use class? So let's see here. So I define write 1 is equal to pick up home and drop to airport. Write 2 is equal to pick up mall, drop to station. So I print these details. Okay, so these are the details. Now what happens if I write big complex programs without classes? Okay, so these are the three common problems that you see. You lose structure enforcement. Okay, it's easy to make typos. Like uh, every time you have to rewrite this. So sometimes you may make mistake. Like instead of drop, you might say drop, spelling mistakes. So the chances of that is there, and no built-in way to associate behavior like calculate fair. So there is you have to write a separate program, calculate fair. There is no built-in behavior for this when you write these kind of programs without classes. So what classes gives you is a structure. So it already gives you ready-made structure. You can quickly go and use it, take that complete structure, build according to your needs by taking that structure. So it's like a template. So think of it like a mold of a brick which is already prepared of different sizes. You can just put the mud and prepare different types of uh, bricks, different sizes of bricks. So that kind of an analogy we can take. So classes give you structure plus data plus behavior. So it gives you all three: structure, data, behavior, all bundled together. So it's easy to scale and maintain. So one important thing is, as your requirements increases, using classes becomes easier to scale the software programs also. Okay. So let's look at one of the exercise. We have to create a class of book with no attributes or methods, then create two objects from it. Okay. So how do I create it? Just simple. I say class book and just say pass. Since I'm not passing any data here, just creating an empty class and calling the class by declaring the object B1 and B2. Okay. So far we have seen classes. What are classes? Classes acts as a blueprints. Objects are real. That means you create objects by accessing the blueprints, which is personalized to you. So everybody books their own ride by selecting pick up and drop. So that kind of analogy you can think. So it's personalized versions of that blueprint. You can organize data better and reduce errors using classes. Okay. So next, we'll see attributes and method. So inside the class, we have just seen a sample like a class with no attributes and method. So if you remember what we have said, class, what is the definition of class? A class is a blueprint that defines how objects should be structured. So a class can contain, a class will have a data and behavior. So now we'll use these attributes and methods to define uh, this data and behavior and structure of the class. So let's see. Every class will have underscore underscore init underscore underscore. So this is a special method. So what does it do? It automatically uh, uh, it automatically uh, calls an object when object is created. So when object is created, this method is called automatically. So what does it do? It initializes attributes. And we have one more method called self. So self is a reference to the current object instance being created or accessed. For example, let's say we have two users, user one and user two. User one is accessing a ride, user 2 accessing or also accessing red. So they both are accessing separately or with different devices. So now you can think of it like whenever they access this, now underscore underscore init, this method makes sure that all the attributes inside the class like self, pickup, drop are particularly everything is assigned to this particular user, user one. And whatever whatever entry like pick up or drop he's going to enter, it will be personalized to him, user one only, pick up and drop. So that is what the self means. So same thing applies to user two also. So that means user one will not be able to see the right details of user two, and user two will not be able to see the right details of user one. So when user one is entering pick up and drop, that instance is personalized to him only. So that is where the initialization of class happens, and all the objects and methods of the class will be shown to him, and he'll be able to enter pick up and drop. That will be personalized to user 2 only. So that is what underscore underscore init and self method is. That means we are personalizing this class to whoever may be accessing it. So let's say tomorrow user 3 access it and user 4 access it. So for everyone, by defining init and self, we are personalizing this class for them to use on their data. So now let's see. I have defined a class ride. So inside the class, I have to define init special method. So what is init? So let's see here. So it's a special method. So inside every class, I need to define a special method, which is called automatically when an object is created. So I don't have to specifically call this I don't have to specifically uh, uh, call these pick up and drop variables or with pick up and drop attributes. So when I create an object r equal to write one, then automatically this part will be called and all this data will be all this behavior will be brought here. So I just need to enter the pickup and drop location. Okay. Now I'm doing another write. I can call just the class name and pass this pickup and drop. So that way, all the behavior inside it, like show details, everything from the class will be passed on to object one. Every behavior from the class will be passed on to our object, user one or user two. So defining underscore init and self means this template's behavior by default will be passed on to whoever calling the class. So if I run it, like I say, right from home to airport. Okay. So you can read this in detail to understand what happens behind the scenes when you write a class and when you write underscore in it and how initialization happens, how data access and methods work. Okay. So now we saw underscore init and self. So what happens if you do not use these special methods like underscore init and self? Okay. So, okay. So here is an example. So I'm writing a class. I'm defining the function called setup. So I didn't write underscore init here. So by default, every class starts with def underscore init. That means use this default function by default. But I didn't define that underscore init. I just said setup, self, pickup, and drop. So when I write it, I can I can execute the program. But what happens is you need to specifically call this function. For example, I forgot what is the function name inside my class. The program will not run. So it says object has no attribute setup class. So it will error out with that. So now if I define underscore init, even if I forget or do not remember what is my function inside my class, I can directly run my program. So that is the advantage underscore init and self gives you. So underscore init will make sure whatever the definition, whatever the attributes that are there in the class, it lets you use automatically along with the class. So there is no need to specifically define this setup method. So if you do define manually, you need to remember this and you need to use this manually. So again, it makes conversion. So again, it makes uh you know calling the classes conversion. Okay. So we can make this underscore init. Okay. So why use underscore init? As we already discussed here, it automates the setup. So I don't have to remember the what is the setup function inside my class. I'm already using that by defining underscore init at the time of object creation. So it reduces the risk of forgetting initialization. So every class that we create, we have to initialize it. So if we don't initialize it, we will not be able to use it. So underscore init, what it does it it automatically initializes the class for you when you define it inside the class. So that makes uh, that makes your code writing more easier, or it makes uh, it makes your life more easier. You don't have to remember to specifically initialize that class. You can just call the object, and initialization part it will take care itself. Okay, so here is a mini exercise we have. Okay, create a user class with underscore underscore init that takes name and email and a method called describe. Okay, so I have created a user class and I created a uh, function definition inside the class with initialization. So this is my setup function. So all the methods, attributes that I'm going to use with my class, I will define it here. And I'll say self.name is equal to name, self.email is equal to email. Then I'll write a describe function. Okay. So this is how I can write classes and define initialization setup so that I don't have to worry about specifically initializing the class when I'm creating an object. So this will automatically take care by itself. Okay. So far, let's recap what we have learned. We have learned how to create a class and how underscore underscore init underscore underscore sets up attribute during object creation and helps automatically initializing the class when we create an object. So what is an object? Here is our object. R is equal to right. So when we call this, automatically it takes care of initialization and it creates the object. And self connects attributes and methods to the object. So self means each attribute, like each attribute, self means each attribute is personal to this object. So this is my, let's say, user one. This is user two. So user one data is pick up from home to airport. User two data is pick up from bus stand and drop it to airport. So when I say self, this data is personalized to user one. What is their data? Home and airport. When I say self here, what I'm saying, user two object is created and the bus stand pickup location and airport drop location is personalized to this user two. So that is what it means. Okay. Okay. So far we have seen what are classes and what are objects and what methods does classes use, how to create class, and what is underscore underscore init underscore underscore in the class, and how it helps automatically initialize the class when you call an object, how self personalizes an object when you call or create an object. Okay, so that's it for today. We'll meet tomorrow and see further of object oriented programming and learn further object oriented programming concepts. Okay, thank you. Bye bye.